Welcome back to Middle School Math with Miss Betsy. We are continuing our discussion of introductory geometry today. We're going to be discussing two different classes of polygons. We're going to be talking about triangles, which of course have three sides. We're going to be talking also about quadrilaterals, which are four-sided geometric figures. But before we get started with those, let's go ahead and pray and see what our lame joke is, all right? God, you're awesome, and we are grateful for who you are. We're grateful for the fact that you love us unconditionally and that you're always present with us, that you're never too busy to listen to us when we cry out to you. Father, we love you today, and we thank you for the ability that you give us to think and to reason and to comprehend new material. Help us to understand the material before us. Help me to present it well. In Jesus' name, amen. All right, this is just such an old joke that maybe you haven't heard it for a while. Why did the little boy eat his homework? And no, it was not from cooking class. Why did he eat his homework? Well, his teacher told him it was a piece of cake. So if I tell you in your math class, hey, this is a piece of cake, don't eat the paper, okay? Last I knew, y'all, we're not goats who have been known to eat paper. So we have two objectives in our section today, which is section 8.4, and these are what they are. The title on our book simply says Triangles and Quadrilaterals. What we're doing is we're going to learn to classify triangles by their angle measures or side lengths, and we're also going to learn to classify quadrilaterals. So what do these objectives really tell us? Exactly what I said. We're going to study three-sided figures and four-sided figures, but we're going to find that there are a bunch of names that are used to describe these three- and four-sided figures, and you have to know them all, okay? Acute triangle, equilateral triangle, isosceles, right, and scalene triangles, parallelograms, rectangles, rhombus, square, and trapezoid. So again, as I've been saying a lot lately, a lot of the work involves knowing definitions. So first we're going to talk about triangles. Triangles have three sides and they have three angles. And I can't spell triangles this morning. This is being recorded on Valentine's Day. Here in Texas, it is a drop-dead, gorgeous day, triangles. And I'm going to go out and go for a long bike ride when I get done recording some videos. Triangles have three sides. They have three angles, and they have three vertices. And remember that vertices is the plural of vertex, and vertex is the common end, the common joint place of where an angle is. And we have a variety of names for triangles. We have to know what they all are. We have an acute triangle, and an acute triangle, and I'm just going to use the triangle shape as an abbreviation for triangle. And we talked about angles in our last lessons, and we talked about obtuse, and we talked about acute. And acute angles, they said, oh, they're just these cute little angles, but all acute angles have to be greater than 0 degrees and less than 90 degrees. And we also know that a triangle has 180 degrees is the sum of the angles here, but an acute triangle is one that has all three angles are less than 90 degrees. I was trying to combine three and less in one word. All three angles measure less than 90 degrees. That's what an acute triangle is. The angles might be all the same length. In an isosceles equilateral triangle, which would mean all three of those angles are 60 degrees. We're not going to talk about that right now, but typically If you have an acute triangle, you're going to have different measures to those three angles, but you do know that taken together, when you sum together those three angles, they're always going to have to be equal to 180 degrees because that's the total number of measures of angles. I'll get the right word eventually. That's the total number of degrees, which is the measurement of the angles of a triangle. Now, we also have a right triangle. A right triangle has one of the angles is a right angle. And a right angle is like at a corner. And a right angle, we put that little box there, and that tells us that the measurement of this angle right here is 90 degrees. Now let's think about this. Now if you look at this picture, the way that I've drawn it, both of these angles here look like they're acute angles, don't they? They look like they're less than 90 degrees, and that's true. But why could not one of these be an obtuse angle? Do you remember what an obtuse angle is? An obtuse angle is an angle that is greater than 90 degrees. So the mouth of that angle, if you will, the jaw is open wider. There's an example of an obtuse angle. And a right triangle cannot have an obtuse angle in it as well. And why is that? Obtuse angles are greater than 90 degrees. So let's say that it's just very, very, very slightly obtuse. That it's 91 degrees. What's 91 degrees plus 90 degrees? That's 181 degrees, isn't it? And how many degrees are there in a triangle? There are only 180 degrees. So if you have a right triangle that contains one right angle in it, both of those other angles have to be acute because there can only be a total number of 180 degrees when you sum together the three angles, the measures of the three angles in a triangle. Now the next one that we're going to talk about is an obtuse triangle. We know triangles have three sides, three angles, and three vertices. An obtuse triangle has one angle that is larger than 90 degrees. One angle is greater than 90 degrees. How do we know that? The definition of obtuse in this geometric format here, geometric meaning here is that an angle that is greater than 90 degrees. So this would be an example of an obtuse triangle. And I think what I'm going to do here is draw an obtuse triangle this way. And you have this one angle here that is clearly greater than 180 degrees. Now I'm going to take a second here and not use this little abbreviation for triangle, lest you think that that's what the appearance of the triangle is. Let me make sure that we are not being ambiguous. So we have an obtuse triangle, we have an acute triangle, and we also have a right triangle. Acute triangle, all three of those angles have to be less than 90 degrees. So that is an example of an acute triangle. This is a right triangle that one of the angles is 90 degrees, and we're going to use that little box. Remember, use that little box in the corner. That indicates that we have a right angle. And here we have an obtuse triangle where one of those angles has to be greater than 90 degrees. The next one that we want to talk about is, let me see, how about We've talked about an acute triangle. We've talked about a right triangle. A scalene triangle is a triangle that has no three angles the same. It doesn't even have two angles the same. An example of a scalene triangle, it could be obtuse. It could be a triangle that has a really, really big angle and then some small ones. A scalene triangle, the angles could be similar to one another, but not the same. With the scalene triangle, all of those angles are different, and it's difficult to draw a scalene triangle. You just have to recognize that they're different shapes. An isosceles triangle. That's how you pronounce this funny looking word here. Learn to spell it. I-S-O-S-C. I-S-O-S-C-E-L-E-S. An isosceles triangle is one where you have at least two of the angles are the same. And that at least is important. I-S-O-S-C-E-L-E-S. An isosceles triangle. And I'm going to underline this to emphasize it. At least two angles are the same. A good example of an isosceles triangle is the one that you're used to seeing. It's sort of like if you take like the waffle cone at Brahms, the pointy ice cream cones, and you cut it in half just in one plane, so you don't see the circle, but you just see the shape of it. Here's my ice cream cone that I'm holding upside down, and I cannot draw it perfectly. You could not draw it perfectly either, but the idea of an isosceles triangle is that at least two of these angles here are the same. And when you have that little circle, that little connecting line there, that indicates it's an angle. And when you use that little hash mark, that means that that angle has the same length. So isosceles triangles have at least two angles that are the same, but they can also have three angles the same. And when they have three angles the same, it's called an equilateral triangle. Equilateral triangle. An equilateral triangle has all three angles the same, and that means that each of the angles in an equilateral triangle has a measure of 60 degrees because they're the same. Obtuse, acute, isosceles, right triangle, equilateral triangle. Those are the most important ones to remember with when you're talking about triangles here. So what do I have? I have obtuse. We didn't even have that up here on the vocabulary list, but if it's an obtuse triangle, that's one that has an angle that is greater than 90 degrees in it. That's an example that I had erased of an obtuse triangle. All right? Now, there is something that is important to make sure that we know about triangles. I want to look from my notes to what I have here just to verify something for a moment. Let me make sure that I speak it the way that I want to. Now, if you have two sides that are same, if you have an isosceles triangle, I'm going to go ahead and erase all of this so that I can draw you a picture of what I'm talking about. And this is a geometric truth that you will use when you get into geometry. Here's a big isosceles triangle. And this is how you know that it's an isosceles triangle. If you look at that, it's clearly not drawn. Those sides are not exactly the same. But when you put that little hash mark in there, that's the mark that tells you that these sides are the same. And with a triangle, the angles that are opposite sides that are the same length, those angles have the same measure. I have this side, and I go over to the angle opposite it, and this side, and I go to the angle opposite. And because the sides have the same length, these angles have the same measure. That's an important fact to remember. The angles that are opposite equal sides, opposite equal sides have the same measure. And I can't spell measure. Same measure. Now if you look at this triangle right here, it should be pretty obvious that none of these are a right angle. This is just a regular isosceles triangle. Remember that I said an isosceles triangle has at least two sides that are the same. So this is just a plain old ordinary isosceles. Isosceles. Now I want to draw an isosceles right triangle. Let's see. Where do I want to draw? This is a little bit harder for me to draw, but I'm going to do my best. This sort of looks like a shape of a pyramid. Now, that's as close as I can draw to a right angle. But you don't know that it's a right angle until you put that little square in there. That tells me that this is a right angle. So this is an isosceles and the sides are the same. Those marks on the triangle tell me I have an isosceles right triangle. I have a right angle and I have two sides are the same. Isosceles right triangle. Now, the measure of these angles here is 45 degrees. How in the world do I know that? Well, what do you know about the angles that are opposite sides that are equal? We just talked about that. The angles that are opposite equal sides have the same measure. So how do I know that those are both 45-degree angles, and why can't they be 50-degree angles? You know, two 50-degree angles, because it just says they have to have the same measures. Well, the reason that you know that these are both 45-degree angles is because one of those angles is a 90-degree angle. That you already know the right angle is 90 degrees. So if you have 180 degrees to begin with, and you subtract 90 degrees from that, what do you get left? You have 90 degrees. And if the angles have to be, the measure of the angles has to be the same here, you have to divide 90 in half. 90 divided by 2, and that is 45 degrees. So, it's important that you understand you can have an isosceles triangle. You can have an isosceles right triangle where the measure of the angles are 90, 45, and 45. You don't know anything about the measure of these angles except that two of the angles are the same. And then you can also have an isosceles equilateral triangle. The isosceles equilateral triangle is one that has all three of the sides are the same and the measures are the same. We already drew one of those, because the sides are the same, the angles are the same, and the measure of those angles is going to be 60 degrees each. So an equilateral triangle can also be called an isosceles equilateral triangle, but equilateral triangle is more specific. And you can be thinking, oh my goodness, a lot of vocabulary. Yeah, there is a lot of vocabulary. Next thing that we're talking about is a parallelogram, and we talk about parallelograms and trapezoids. And these are what quadrilaterals are. Let me read. It says quadrilaterals have 4 sides. That makes sense. Quad, 4 sides, 4 angles, 4 vertices. Quadrilaterals. 4. 4 sides, 4 angles, 4 vertices. Here would be an example of a quadrilateral. And all a quadrilateral is a 4-sided geometric figure. We have 2 specific ones that we're going to talk about right now. We have a trapezoid and we have a parallelogram. And we have a parallelogram. What do you think is going to be specific about this parallelogram? Look at the meaning of the word and well, parallel. Something's got to be parallel in the parallelogram. Okay, but first we're going to talk about a trapezoid. A trapezoid it's a 4-sided figure that has at least one. Not only one necessary, but it has to have at least one pair of parallel sides. Now a good classic example that we have for a parallelogram is going to look like this. We have 4 sides, and that's actually a very bad drawing. Let me see if I can do a better one for you. These 2 lines here are parallel. Do they look parallel? Not necessarily, but you can tell they're supposed to be. But when you're in geometry, they're going to tell you that in the parallelogram, or they're going to tell you that that line segment AB is parallel to line segment CD. So you cannot trust only the appearance of an object. You have to know that they're going to tell you, okay, this is parallel. If they tell you it's a parallelogram, which of these 2 line segments are parallel? Well, not these 2. They're going to cross pretty quickly, aren't they? If they tell you it's a parallelogram, you know that AB is parallel to line segment CD. If they don't tell you it's a parallelogram, they could also say AB is parallel to CD, and that tells you that it's parallelogram, that these 2 lines are parallel. Trapezoids have at least one pair of parallel sides, which means they can have 2. If they have 2 pairs of parallel sides, we call that a parallelogram. And you know what a classic example of a parallelogram is? You don't see them as much as you did when I was growing up, but you drive out in the country and you come to an old farm. And when the barns are built originally, they're square. You know, the angles are square and they're standing like this. And what happens over time? Well, they shift and you have a leaning barn. That leaning barn is a good visual memory jog for what a parallelogram is, because when that barn started off, the roof was parallel to the floor. The sides were parallel to one another, like a square or a rectangle. So the sides here are parallel, but over time it leans over to one side. So the sides are still parallel to one another, but they don't have square sides. So this is what a parallelogram is. A parallelogram is a trapezoid that has two pairs of parallel sides. So parallelogram has two pair of parallel sides. All right? Now, I said both of these are trapezoids. But we call this a parallelogram and we call this a trapezoid. What are we talking about? We're looking for the most specific or the most precisely descriptive name for a figure that we can come up with. Let me erase all of this and show you an example of what I'm talking about. Let's say that we have this dog. We could call it a dog. We could call it a retriever. We could call it a golden retriever. Now, I am not a dog person. I'm more of a cat person. Retrievers are beautiful. It's obviously a dog. If you want to describe it a little bit more specifically, you're at a dog park or something, see that dog over there, it's like, there's a whole bunch of dogs. Well, it's the one over there in the corner that's a retriever. Well, I see a golden retriever, and I think I probably meant labs instead of retrievers. Seeing that I don't know my dogs well enough, you have a lab. It's that lab over there, and they're saying, oh, wait a minute, I see a chocolate lab, I see a golden lab, I see a black lab. Well, I'm talking about the golden Labrador retriever, okay? So it narrows it down as you get more specific with your description here. A dog saying, hey, see that dog over there? Well, that is meaningless if you're at a dog park and there's a bazillion dogs running around. So you could say polygon if you wanted to describe a geometric object. And you would say, gee, thanks, that's really helpful. Doesn't limit it at all. All I know about a polygon is that it is a many-sided figure. And I could say, well, okay, it's a triangle. I said, okay, that helps me. Now I know that there are three sides to it. Well, what else can you tell me? Well, it's an isosceles triangle. Okay, that tells me that at least two of the sides are equal. You can say, oh, it's an isosceles right triangle. And I can say, oh, I can pick it out now exactly because an isosceles right triangle has two sides that are the same length, but it also has a right angle in it. So with your whole big old table full of different polygons, as soon as I say isosceles right triangle, now is this a polygon? Sure it is. It's a many-sided figure, but that's not very specific. So when we're naming all of these geometric figures that we are working on, we're going to name them as specifically as we can. So we're going to go back to talking more about the quadrilaterals. Now remember, they have four sides, they have four vertices, and they have four angles. So when you have a parallelogram, this actually comes from example 1. Parallelograms, their opposite sides have the same length, opposite angles have the same measure. This is an important fact that you have to know. Parallelogram. Opposite sides have the same length. I'm sorry that you see my back so much. Parallelogram has two pairs of parallel sides. Those parallel sides have the same length, and the opposite angles also have the same measure. And example 1, we are given a drawing and we are told that it is a parallelogram. So here's my parallelogram, and its corners here, vertices here are A, B, C, and D. And they tell us the measure of one of those angles, I think. No, they tell us the measure of two of the angles. They tell us that this measure here is 72 degrees, and they tell us that that measure there is 108 degrees. And I want to make sure that I put this measure here so that if you're looking, that I have this drawing made exactly the way they have it in the book, so that if you should happen to be looking at your book as you go through here, you would see this. Now, the question here, the measure of angle C is 72. The measure of angle D is 108. They want us to determine the measures of angles A and B. And do we have to get our protractor out and measure anything? Do we have some big calculation that we have to make? No, we don't. Opposite angles have the same measure. So, the measure of angle B, remember we learned how to do that, the measure of angle B is 108 degrees. Because angle B is opposite angle D. And the measure of angle A is 72 degrees because angle A is opposite angle C. Okay? So, these angles have the same measure. Line segment BC is the same as line segment AD. Line segment AB has the same length as line segment CD. And if they're going to indicate that line segments have the same length, they will show it like this. And they'll say that BC is equal to AD. And they're talking about the line segment there, and that means that they have equal measure. Now, I'm quite certain that I have seen in books, perhaps the books that I had a long time ago, where they show that little line on the top that indicates it's a line segment. Your textbook here says that we're not going to use that line. But just understand, if you see that somewhere, it's just talking about that line segment, about the fact that these two sides are parallel. All right, now I've got to go back to this other page of my notes. And we have different types of quadrilaterals that we're going to talk about now. We know that the most general description of a parallelogram is that it is a polygon. Has many sides. It's a parallelogram, which means that it has, it's a quadrilateral, which means it has 4 sides. The parallelogram tells us that opposite sides are parallel and opposite angles are parallel. We also have what they call a rhombus. And let's see if this will not fall. It is going to fall. I have a music stand that does not wish to have that much weight on it. You have these other pieces of information that we're talking about. We're talking about a rhombus. That's how you pronounce this thing, rhombus. And a rhombus, the sides are the same. All 4 sides have the same measure. What a rhombus is, it's like a square that's gotten tired and it sits to one side. You know what a rectangle is. A rectangle is a parallelogram, meaning that it has 2 pairs of parallel sides. But it is more specific than a parallelogram because a parallelogram can be a great big long rectangular building, that's gotten tired and leaned on its side. Wow, that was a bad accent. Tired and leaned on its side. A rectangle is a quadrilateral, 4 sides, where opposite sides are parallel to one another and all 4 angles are right angles. That's what a rectangle is. And then what do you have? You have a square. And a square is both a rhombus and a rectangle because it is like a rhombus because the 4 sides are the same. A rhombus, the 4 sides are the same. It's like a rectangle because the 4 angles are 90-degree angles. So we've talked about parallelogram, rectangle, rhombus, square, and trapezoid. All of these are objects that have 4 sides to them. The trapezoid is the least maybe specific of all of them. With a trapezoid, you only need to have 1 pair of sides that are parallel. With a parallelogram, you get a little bit more specific. You have 2 pairs of sides that are parallel, but you have nothing that's said about the angles. Then you get to a rhombus that tells us it's a parallelogram where the sides are the same. You have a rectangle, which is a parallelogram, where you have 2 pairs of opposite sides that are parallel to one another, but the angles are all 4 right angles. You have a square that's like a rhombus with right angles. All right? You have to, if I ask you to describe this object right here, which is a square, what is this object called? You're not going to tell me that it's a parallelogram because that's not specific enough. That's like looking at the golden retriever and saying, go get that dog for me. It's not specific enough. Yes, this is a parallelogram. It's an object that has 2 pairs of sides that are parallel to one another, but it's not specific enough description. All right, moving right along, I want to read to you from page 348. This is their summary of what I just told you. What's the name of a rhombus with right angles? All sides of a rhombus are equal, and when the angles are right angles, the rhombus is a square. Since a square is a 4-sided polygon with opposite sides parallel and equal, and all angles are right angles, it is also a rectangle, a rhombus, a parallelogram, a trapezoid, and a quadrilateral. So always be as specific as you can, or make certain that you answer your question at the level of detail that they're looking for. All right? Example 2 is the final problem example that we're going to go through. We have in rectangle W, X, Y, and Z. Now, what do we know about a rectangle? We know that with a rectangle, opposite sides are parallel, all of the corners are 90 degrees. And in a 4-sided, in a 4-angled object, if you have one angle that's 90 degrees, all of those other angles have to be 90 degrees as well. So here we have our rectangle. And it says that side WX is equal to 7 centimeters and side WZ is equal to 5.5 centimeters. Find the lengths of the other 2 sides, which are X, Y, and YZ. This is a very, very long problem to draw and for me to describe to you, isn't it? And it would be really hard for it to be any easier. The length of WX is 7 centimeters. The length of WZ is 5 centimeters. Let me change this drawing so that this looks a little bit better shape-wise and doesn't mess with our minds. So I have W, X, Y, and Z. WX is 7 centimeters. WZ is 5.5 centimeters. The line segment WZ, or the side that's described that way, is shorter than WX. We want to find XY. How do we do that? It's the side opposite. They have the same measure. So that's 5.5 centimeters. And then you have YZ, which is the side opposite WX. So it has the same measure. That is all that is involved. And this is a very obvious, very straightforward problem, but a lot of your geometry problems are going to be like that. They are straight up simple, provided that you understand and you've learned all of the relationships with the angles and the sides and the objects that are within it. Alright, vocabulary. Different types of triangles, different types of quadrilaterals. Make sure that you know them. If you get stuck, send me a text and I'll be happy to help you. And I'll see you next time.